Model steam engines top tip time part 50. It's been a very strange week for me. First of all, my old dishwasher packed up and leaked everywhere, so I fixed that by putting it on some pieces of wood and then placing a baking tray underneath to catch the drips. For many years I've spent a lot of time problem solving, and I still do it, as you can see in the videos. It's a continuous test of my problem solving ability. The bad news first, the dishwasher started leaking, so I bought a new one, which arrived, and that had a broken door catch. It was picked up the next day and taken back, and another one arrived, and that had a dent in the case. I bought it via Amazon, and I must say their customer service really was first class. That's the bad news. Now the good news. I have prostate cancer, and my PSA level, prostate specific antigen test level, was rapidly approaching 8. But after taking a specific drug for a couple of months, it is now, wait for it, at 0.72, which is quite good. The only trouble is though, as my testosterone level drops, I keep wanting to watch Bridget Jones's Diary and discuss soft furnishings with my first wife. I'm making light of it, but really on a serious note, if you're a male, it's a good idea to get a regular PSA check once you get to about 40. And that's one of the reasons I always say stay healthy at the end of each video these days. It's time to get on with the show. What I'm going to do is make some exhaust adapters, because all of these small engines do not have any exhaust pipe adapters. The threads on the exhaust outlets of these engines are only 3/16 by 40 threads per inch, which is very small. And if I was to pipe these engines using 3/16 by 40 threads, the union nuts would be far too small, and therefore the pipe would be very small. And the whole point of a gas engine is to get rid of the gas in a large volume and very quickly as soon as it's done its work. And a steam engine is a gas engine because steam is an invisible gas, very unlike the stuff that comes out of your kettle and the chimney of steam locomotives, be the traction engines or locomotives on the railway, because that is water vapour. Anyway, on with the job. This is my old micrometer, and I'm just checking that it's set to 0.250, which is 1/4 inch. And I'm going to cut this part of the metal bar to 1/4 inch in diameter. This is a piece of hexagon brass, and I'm going to convert this very plain lump of hexagon brass into an exhaust adapter. 3/16 by 40 threads per inch to 1/4 by 40 threads per inch. I'm machining and threading the 1/4 inch side first, then once it's parted off I will reverse it in the chuck and machine the other side. I've cut the thread using a 1/4 by 40 threads per inch die in my tailstock die holder, and now I'm centre drilling the end to take the union cone. When doing a job like this, always use a centre drill first, for a couple of reasons: to make sure the hole is in the centre of the bar and to form the seating for the union cone. Don't just make a mark with the centre drill and then drill through with a smaller diameter twist drill, because then when you come to refit the centre drill and you get to the tapered part, it's likely to chatter. I'm now drilling a hole in the work using a number 48 drill, and as you can see it has a piece of fuel tubing on it, because this was the drill that I used for drilling the holes in the baseboard. It's most important when making union adapters like this not to use too large a diameter drill, otherwise the 3/16 by 40 part of this will be very weak, and you don't want it to snap off in the engine's exhaust port. In this clip I'm parting off the half-finished union, and in this clip, using a spanner that's not a particularly good fit, and this is why I always use my Barco spanner as a rule, I'm screwing this fitting into a union nut fitted in the chuck. Why am I doing this? It's a hexagon fitting. I could put it in the chuck jaws. But the problem is, the piece of hexagon that's going to be left is very small, and the chuck jaws will damage this. So you get a better finish by doing it this way. This is a very lazy and possibly not the most accurate way to machine a steam fitting. If I was a proper engineer, I would put a piece of brass hexagon in the chuck, I would drill it tapping size for 1/4 by 40, then I would thread the piece of hexagon bar in the chuck 1/4 by 40 threads per inch, and then I would screw my fitting into that. And that way everything would be perfectly concentric. But as this is not a precision item, the union nut is more than satisfactory for doing this. And more importantly, it takes a lot less time to do it this way. I'm currently threading it 3/16 by 40 threads per inch using my homemade tailstock die holder adapter, which again speeds up the job. So that's one of the thread adapters completed. I have to make another two. Mass production for beginners. In this clip I'm just doing a test fit of the adapter into the engine and it fits perfectly. It wants cleaning up on a piece of wet or dry sandpaper to get rid of the sharp edges. I'm really sorry about this, but after that mass production I was in the mood for a bit more piping, so I piped the water pump into the system. I'm test fitting one of the exhaust adapters to the aerial steam engine, just to make sure that it's not too long to go into the exhaust port, and no it isn't, it's fine. Oh dear, where's the Perseus gone? It's evaporated. This is the exhaust adapter that I'm going to fit to the Perseus, but the problem is that it's not in a good place. The union adapter fits, but then the nut doesn't want to go on. I'm quite puzzled as to why these three engines don't have exhaust fittings in the first place. But never mind, I'll make my own. This is my answer to the exhaust fitting for the Perseus. The PM Research 90-degree elbow, and I had to re-tap the thread to make it compatible with all my 4x40 fittings. This part of the job wasn't planned, but in order to fit the exhaust adapter to the engine, it has to come apart. I just remove the cylinder from the bed plate. Then with the help of some Loctite 542 and a copper shim washer, I rotate the part into the correct orientation. So now the engine has an exhaust outlet which is very easy to connect a pipe to and disconnect a pipe from. I ended up using about 1.5 tanks of water to get the water to the level you're about to see in the water gauge. And as you can see, once it appears in the bottom nut of the water gauge, in no time at all the gauge glass becomes half full. I need to make a suitable manifold that will accept 3 pipes from the steam outlets from the engines and combine these 3 steam outlets into one to connect to the condenser. It would have been easy to make both of these manifolds, the one from the boiler and the one to the condenser, identical. That way I would not have had to use some more footage or narrate it, but this one's going to be different. Here I have a piece of brass block in the 4-jaw self-centering chuck in my Smart & Brown lathe. First of all I faced off the end of the block, then I drilled it with a centre drill, drill it all the way through with a 7/32 of an inch drill, and in this part of the sequence I've just finished tapping the hole down the centre, and currently the tap has been withdrawn from the work. You may be thinking, why didn't I make the manifold in exactly the same way and the same design as the one that fits to the boiler? If I put the same type of manifold on the condenser, it's just not going to look good fitted so high up on a smaller component like a condenser. I'm cleaning up the brass block using a piece of 400 grit wet or dry sandpaper. And you know what they say, it's not how you start, it's how you finish, and I want a good finish on this one. I think it looks okay as it is. I don't want to polish it, that would not look good and it would round the edges. Time now to fit the steam unions. I turned down a commercial 5/16 by 32 union and I fitted this in the middle, using a copper washer and some Loctite 542. Then in the same way I fit the 4x40 unions in the rest of the holes. And eventually it looks like this. There are many ways that I could have done this. I could have silver soldered the main pipe into it, but in the end I did it this way with replaceable unions. And here is the finished manifold complete with its pipe attached. All I need to do now is mount this to the condenser. I'm using my Barco spanner for this so I don't mark the nut. Because as you can see in this clip, this nut is right at the top of the condenser and very visible. And now once again it's a small pipe bending marathon to connect the exhaust piping from the 3 engines to this manifold fitted to the condenser. And here's the pipe as it exits the Perseus engine, and this is how the Perseus engine connects to the manifold. And once again, I didn't do this job in one attempt. It's quite difficult to get all the pipe runs to be nice and even. This is shortly before I've finished the job, but as you can see there's a little bit more bending to be done. The reason for fitting a double union on the gas pipeline is so that if the owner of the engine wants to change the gas supply to a normal tap that goes onto a canister rather than this small tank, it will be a very simple job to do. Some manufacturers use 4x32 threads per inch, but Cotswold Heritage use 4x40. The pipe that's fitted to the double union is also 4x40. Now it's time for a test run of the plant. I can't fill this Cotswold Heritage tank because I don't have the fittings, so I'm having to improvise by using some silicone rubber tubing and a pair of cable ties. The plant is now all ready for the steam test, but that's it for this episode. Stay safe, stay healthy, thanks for watching, and I hope you found it useful. please take the time to visit my Mainsteam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.